Hi and Assalamualaikum. So my name is Fatima Ansara. So I'm going to explain to you what is analysis of function 1 and 2. This chapter using the first and the second derivative of a function to obtain a lot of information about the behavior of that function. For example, the first derivative tells us where a function increases or decreases and where it has maximum or minimum points, while the second derivative tells us where the function is concave up or down and where it has inflection points.
The next is the step to solve the problem. First, we need to find the x-intercept and y-intercept. Second, find the derivative value, which is a f prime x. The third one is find the critical value and point. The fourth, construct the first interval table where the graph increasing and decreasing. Next, determine the extremum points. After that, find the second derivative, which is f double prime x. The next, find the inflection value and point, and the last one is find the concave up and concave down.
Let's move to the equation. For the equation, we have fx equal to negative x over 1 minus x plus 4. Firstly, we have to find the x-intercept and y-intercept first. So first, we have to make it as dx over hash x. Fx equal to negative x. For this equation, we can see that we already find for the gx over hash x. Okay, let's move to find x-intercept. But for x-intercept, we have to make it as y equal to 0. Okay, we take this one. This one. Equal to 0 per 1. And then this one multiply with 1 and then 1 minus x multiply with 0. And this is the answer for x-intercept. Now let's move to the y-intercept. For y-intercept, we have to make it x equal to 0. And then we take this equation, and substitute the x to 0. This one. Then we will take 0 and 4 for the y-intercept. Next, let's move to the second step. We have to find vertical and horizontal asymptote. Okay, for the vertical asymptote, we have to let hx equal to 0. Hash x is 1 minus x. Then this is the equation. And then this one. So it will be equal to 1. This is for vertical asymptote. Second one, we have to find horizontal asymptote. Y equal to lim x infinity fx. We have to use this equation to find horizontal asymptote. We will get y equal to 5.
So let's move to the next step, which is determine the function either increasing or decreasing. So we want to use quotient rule to find the prime. So v square. it. Okay, simplify. This is the answer for to find price. So we need to find the x. Fx. So x equal to 1. Okay, so for the interval line, it will be 1, negative infinity, 1. So for the interval table, we pick at the interval value which is negative infinity, 1, and 1 infinity. So for the test value, will be 0 and 2. So the symbol of the sign of fx is negative and negative. So we need to substitute 0 and 2 into this equation. 1, 1, 0, square. So we will be 1 over 1. So it's 1 square. Okay. For the conclusion,
After that, we need to find a concave up and concave down. But before that, we need to find a f double prime x. First, we need to find the f double prime x from the f prime x. So, after we have an answer for f double prime x, we must let f prime double prime x equal to 0, and we get x equal to 1. After that, we write an interval line. We know that the x equal to 1, so the number of the center is 1. Okay, next, we must draw a table to know which one is the negative or positive, concave up or concave down. We need to prove. We need to substitute this test value into the f double prime x equation. So the first one is a negative, which is a concave down. When x equal to 2, we substitute the value x with 2. Minus 2. So for this test value, we get a positive, which is a up. Therefore, fx is concave down on negative infinity 1 and concave up on 1 positive infinity. From this equation, we know that there is no solution for x, so no reflection point. We need to sketch the graph. So this is the graph. From all of the solution that we get, we insert it to this graph.
Conclusion, we must know the concept of rational function and know how to apply the concept in different problems in life. From all of the solution, we already found the x-intercept and y-intercept. Other than that, we found the vertical and horizontal asymptote. Also, we can determine the interval where the function increasing or decreasing. Last one is we found out the equation is concave up and concave down. That's all from us.